Hi everyone, good evening. Welcome to this session. I hope you all are doing good. And today is a second session of this webinar, which is data science for cybersecurity using Python. So yesterday we saw the what is cybersecurity or why to learn cybersecurity. Okay. Then what is data science, its scope, why to learn data science in cybersecurity. Okay. What is cybersecurity data science? Okay. And we also saw the basics of Python, how to install the Python. Okay. And then we saw the data wrangling using NumPy and pandas. Okay. So yesterday we also saw one example about anomaly detection. Okay. So now we will start from the our second example, which is of anomaly detection as well. Okay. And this is gonna be the again the yet another simplest method of machine learning, which is DBSCAN. Okay, we know that what is anomaly detection. Basically, from our past data, past transactions, or you can say that past history. Okay, so from that, okay, as a data scientist, okay, as a data science professional, we have to find out the suspicious activity, or we have to find out the fraud or some abnormal activities. Okay, so that is nothing but anomaly detection. And from large amount of data, finding one or two transactions which are default one, it's gonna be a very complex task. So for that, we are gonna use Python, okay, to apply our analysis on our data set to find out the abnormal activities or the default transactions. So yesterday we saw one algorithm of machine learning, which is support vector machine. And see, with the help of support vector machine, in that we have one specific algorithm, which is one class SVM, also known as one class support vector machine. So by using this, we found multiple anomalies in our data. So here, basically, our data is so small. Okay, this iris data is small, around 150 observations are there in the data set. And by using few libraries like NumPy, Pandas, Matplotlib, and sklearn, we solve this problem. Okay. Likewise, as we have these many libraries, and by using these libraries, we can apply anomaly detection on our data. But here you can see that this is our another algorithm, which is DBSCAN. Okay, in data science, in machine learning terminology, this full form of this is nothing but the density based spatial clustering of applications with noise. Okay, because this is one of the algorithm of clustering, also also you can say that the unsupervised machine learning algorithm. And with the help of this, in this algorithm we are just using some densities. Okay, or you can say that the distribution, data distribution. And how you can find out the data distributions? By using the similarity between the data points. Okay, and by using the similarity between the data points, okay, we apply this algorithm on our data. Okay, so before start executing the code here, before start executing the so before start executing the code, let me just go here in the kernel section, okay, and let me just go and restart and clear all the output. Okay, okay, great. So here first, okay, for applying DBSCAN clustering, okay, we all know that there is a one library in Python, okay, and we are gonna import the DBSCAN algorithm or DBSCAN method for applying on our data set, which is nothing but the sklearn library. So see, before importing sklearn library, let's first go and import the NumPy, pandas, and matplotlib library. As I already told you about these packages, okay. So basically, why we are using NumPy library? To create the n-dimensional array as well as to apply some statistical methods on the data, or to find out the some basic statistical figures. Okay, now why to import pandas library? Because first thing is to read the data. See here, we just applied the pandas library over here, okay, to read the data. Then with the help of pandas library, we will able to pre-process the data. Okay, likewise, see here, with the help of sklearn library, we will able to pre-process the data too. Okay, but okay, if we are just doing the pre-processing task, okay, without, if you don't want to apply some machine learning libraries, so then instead of importing sklearn, you can easily go with the pandas library. Okay, after this we are going to import sklearn library. Then in the sklearn library, we have one module which is cluster. Okay, and in that module we have an algorithm which is DBSCAN. Okay, and here with this line of code, we are just importing this DBSCAN method. Okay, now again, because this is the data, okay, so first thing is to pre-process the data. Okay, so for that we are gonna import standard scalar method from the pre-processing module of sklearn package. Okay, as well as we are going to import normalize as well as PCA, principal component analysis. Okay, so let's go and execute this cell. Okay, now here you can see that I'm executing multiple lines of code. Okay, because I wrote this all the code in a one cell, so it's easy in Jupyter Notebook to run multiple line of code. Okay, just type all the code in a one cell and you will be able to run that particular cell. Okay, in sklearn, okay, in sklearn we have the modules, and in the modules we have several methods. Okay, so without importing, okay, without calling sklearn, we can't import DBSCAN. Okay, yes, we have several packages, okay, other than sklearn. You can use that too, but again, if you are using particular package, okay, there is no such package for a DBSCAN, okay, particular like that particular method. But in Pycaret as well, in sklearn, okay, there are many modules, and in that many modules you will see that many algorithms are there. Okay, so for that you have to first call the sklearn, then you can import DBSCAN. Okay, so after this, okay, this is my data. Okay, and you will see the data over here. Okay, so see, this is my data in the same folder. Okay, also you can see the see over here, this is my data. Okay, and here you will see the code file. Okay, so now, okay, with the help of read underscore CSV method of pandas library, it's very easy to read CSV file. Okay, after this, okay, here you can see that customer ID. Okay, in the data, okay, we have one customer ID column. Okay, and that particular column is not important column for our analysis. It's, you can say that, the irrelevant column. Okay, so this ID column, okay, we have to drop that particular column. So that's why, okay, we are gonna use the same pandas library, because see here, we store this all the CSV file as X. Okay, all the data as X. And now I'm gonna use this particular data, and I'm gonna applying the drop method on that data, and X is equal to 1, which means drop the particular column. Okay, after that, here you can see that, okay, in the data there will be some missing values. Okay, so for that purpose, missing values means what? You will find that some cells are the empty cells, so those are nothing but the missing values. So I'm gonna use the method which is a function fill. Okay, fill, and in place equal to true, it's automatically it will fill all the missing values. Okay, and here you can see that after this I'm gonna just see the first 5 rows of our data. So here you can see this. Okay, so basically, see, we read the data, we drop the first column, and then we apply again the fill NA. Okay, fill the missing values. Okay, fill NA method on the data to fill the missing values. Okay, and see, with the help of head method, you can easily see the first 5 rows of your data, and you can even use the tail instead of head. You can use the tail, but then you will see the last 5 entries of your data. Okay, now here in the data we have so many columns: balance, bank frequency, purchased, okay, one of purchases, like that. And you will see that their entries, okay, the particular entries are over here. Okay, now here you can see that, okay, in the column, okay, first thing is that if we have to apply any pre-processing step, okay, so for that we have to just just extract the column names. Okay, so you can do one thing, you can go and manually just select the column or copy paste the column names. Okay, but in Python you can use just x your data dot columns. With the help of this you can able to just extract all the column names. Okay, and by using the len, okay, this len method means you can just find out the length of your x. Okay, so see here, so see, in the index means these all are the column names. First starting with the balance frequency, like this, balance frequency, to the tenure. Okay, see here, this one is the last column name. Okay, now if you wanna apply particular pre-processing step on particular column, then you can easily just copy and paste this particular column and you can apply that one. Okay, or number of column as well. And see here, this one, okay, this code says that the number of rows which is equal to length of x, means here you can see that total rows are nothing but the 8950. Okay, in the data set. Now this is the one of the part of the exploratory data analysis, which is nothing but the describe method. Now in describe method, here you will see that, okay, the count, and the count is nothing but for all columns count is same, because number of rows for all column is same, means you can say that yes, there is no null value. Okay, or you can say that missing values, because we already fill all the missing values over here. Okay, now after that, mean. Now here you can see that for balance column, okay, for this particular column, mean is this 1564.47. Okay, for balance frequency you will see this mean. Okay, means the average value for each column. See, average value for each column. Now from this table you will be able to decide whether you have to apply the data transformation method on your data or not. So see, from this table you will be able to explore many informations like this. See, just by looking at the mean you can say this, okay, the balance is the average balance is nothing but the 1564. Average balance frequency is nothing but the 0.87. Likewise all the averages of all the columns. Okay, now many times in the data set there are some outliers. Okay, so on the basis of average, okay, you can't just say that yes we have to apply some data transformation techniques on the our data set. So for that purpose we are gonna see the standard deviation. Okay, now standard deviation finds out the variation between the data. Okay, now see this variation between the data. This is the variation between this particular column, this is the variation between this particular column. So you will see that variation is not same for all the columns. Okay, which means that at the time of building the model, okay, if we have to build the model, so if I'm gonna use all the column for building the model, then only few columns which shows the highest standard deviation, highest variation, okay, those column will have a highest weightage in the model, okay, for creating the model. So then if we go with the original data without any pre-processing, then there will be a problem in the model. So to avoid that problem, we have to transform the data. We have to transform the range of each and every column. Okay, because variation of each column is not same. See here, variation of each column is not same. Okay, so to transform the data in the same range, then you will see that variation. Okay, then there is no problem. Okay, because we are transforming the data or merging the data in a same range. Okay, so here first you can see that the balance minimum value is 0 and balance maximum value is 19,043. Okay, like this you will see that the minimum value for balance frequency is 0 and 1. Okay, like this all the purchases, okay, one of purchases like this. So just by looking at this table, okay, we decided that we have to apply data transformation technique. Okay, and there are two main techniques of data transformation. Okay, you can use the standard scalar method, which is also called as the standardization method, or you can use the minimum max scalar, also called as the normalization method. Okay, or you can also use the uh, original formula of normalization method. Okay, so if you are applying the standard scalar, which means that you are converting the range of each column from any different range, let's say 0 to 19,000, okay, to -3 to +3. Okay, means we are just transforming the range of the data. Okay, now why to transform the range of data? Okay, because at the time of model building we should have the columns with same weightage. Okay, so that's the reason we are transforming the data, okay, or the range of the data. So see here, this is the scalar, which is called as a scalar, and we store the standard scalar method as the scalar. Okay, and now here you can see that we're going to apply this standard scalar method by using by just calling scalar dot fit underscore transform. Okay, now by just saying that fit underscore transform on x, okay, means go and fit the data, means just find out the mean and the standard deviation and apply the standard scalar. Okay, there is a formula for this, which is nothing but the one observation minus their mean. Okay, let's say this is an observation. Okay, where it is, see, this is the one observation. Okay, minus the balance mean divided by standard deviation. Okay, and this will give you the one value. Okay, in between -3 to +3. Okay, and that's what we are doing on each and every columns observation. Okay, so after this, okay, after applying fit transform method on our data set, okay, here you can simply say this. Okay, this is nothing but our standardized data. Okay, and you have another choice. Okay, just go and simply apply normalize. Okay, as I already said, there are two methods for transforming data. First one is a standard scalar, second one is the normalized. Okay, you can create one function for minimum max, and you can apply the normalize the same function. Okay, but in sklearn, okay, you will get the normalized function and you can apply this on your data too. Okay, without creating any function. Okay, so let's go and run this. Okay, now we have the two data. Okay, two data. First one is a standardized data, second one is a normalized data. Okay, so after just getting the standardized and normalized data, okay, so now we have two choices for selecting data. Okay, you can either choose the formula of normalize is nothing but the x minus minimum value divided by maximum minus minimum value. So again the same, this maximum you can use this minimum and maximum value, and over here let's say this is a x. Okay, one observation. Okay, and you are just using this the same columns minimum value and same column maximum value. Okay, and you are just finding out, you are applying this formula on each and every observation. Okay, on your data set. So after this, here you can see that now we got the standardized data or transformed data. Okay, so here you can see that now the second problem in our data. Okay, first thing is that there is a range problem. Okay, now we convert the range, okay, from any different range to the same range. Second problem is the multicollinearity problem. Now what is multicollinearity problem? So basically at the time of creating the model, we should have to check these two things. Okay, first the range, second is the multicollinearity. Now multicollinearity is nothing but the, if you are building the model and in the data there should not be the relation between the columns. Okay, either positive relation or the negative relation. Okay, the column should be uncorrelated. Okay, but see here, few columns, many times you will find that in real life scenarios many columns are dependent on each other. Okay, there should be relation, okay, between the columns. Okay, let's see, there is a relation between balance and purchases. Okay, like that. So for transforming the columns from correlated columns or the related column to the uncorrelated column, okay, you have many ways. Okay, you can just go and drop one related column, means, see, for finding the relation between the columns you should have two columns, then only you can find the relation between the columns. Okay, so if you drop the one column, okay, which showing the highest relation, okay, then you can simply go with the another column. Okay, but if you don't want to drop any column, okay, so you can simply use principal component analysis. Okay, now there are some pros and cons of principal component analysis too. Okay, but that will not be the main problem is to just convert our data from correlated data to the uncorrelated data. Okay, means the dependent columns to the independent columns. So principal component, okay, why we are using principal component analysis? First, to convert data from correlated data to uncorrelated. Second thing is that if there are multiple columns, okay, so see here, this is our data. In the data, around 900 observations are there, 9,000 rows are there, and more than 10 columns are there. See, more than 10 columns are there. So many times you will find that, okay, data is updating, okay, because your company just extracting data each and every second. So data is updating or data is increasing each and every second. So at that time, okay, your system is not capable to run your data each and every second. Okay, so for that purpose, okay, you have to just pre-process the data. So you can say that this is yet another the pre-processing step, okay, of reducing your data. Okay, see, these are, you can, I can say that m number of column, let's say. Okay, so here what I am doing is we are just applying the PCA, and I am saying that just use the n components equal to 2, which means that just go and collect the first two principal components only. Okay, so here you can see that by just finding out the only two principal components, so this is again the yet another, you can say that the linear combination of this all the columns, okay, which is nothing but the first two principal component. Okay, but you can create the m number of principal components, which is same as this number of columns. Okay, but instead of all the columns, I'm just using first two principal components. Okay, so that's the beauty of using principal component analysis, and again that will give you the, again the near about the same accuracy. Okay, as you are using this data, instead of, if you are using PCS, then you will see that yes, there is some points, you will just lose some points accuracy, but you will see that your model is good enough. Okay, there are less false positive and there are less false negative values. Okay, so that's the thing. So after this, okay, after just calling the principal component analysis with n components equal to 2, okay, and storing it as a PCA. Okay, now I'm going to apply this PCA on my data. How you can apply the PCA on your data? Just by using the fit transform method. Okay, and now after this, see, you got the data which is reduced one. Okay, and now basically this data is in the array format. So what we are doing is we are transforming the format of the data from array to the pd.data frame, because we want the data into the format of data frame. Then we can easily apply the DBSCAN clustering. Okay, so here you can see that these are the column, all the list. Okay, so here you can see that this is a small code, okay, for just finding out the all the column names. Okay, so here let's go and run this. Okay, and after this, okay, after getting this data, so see, this is the main data, okay, which is the reduced one. Okay, and I'm gonna use the DBSCAN method. Okay, I'm gonna apply the DBSCAN methods with these parameters, which is nothing but the EPS, okay, and the minimum samples. Okay, and by just applying this EPS and the minimum sample, you will see that I'm gonna fit this DBSCAN method on the data. Okay, now basically here you can see that while we are just applying the DBSCAN, okay, we are just using these two EPS and minimum sample. Now most of the time, okay, there are many parameters. Okay, there are many parameters. Now it's totally depends on you to how you have to go with your model. Okay, so I choose the EPS. as a 0.05 and minimum samples equal to 10. Okay, because see, in the DBSCAN clustering, first thing is that we are just finding out the, you know, the first points, nearest points depends on the similarity. So that's why we have to add few parameters, or even if you don't add the parameters values, then only it will take the default values and it will give you the output. Okay, and after this, okay, after fitting the model on the data, here you can see that I'm gonna find out the labels. Now labels is nothing but the cluster. We just split the data into different clusters. Okay, we'll visualize this labels, okay, into the, okay, after some coding part. Okay, see, here we are gonna visualize those labels. So here you can see that I'm gonna use the NumPy library for just finding out the unique labels. So there are three unique labels. Okay, -1, 0 and 1. Okay, and here you can see that these are the hist, you can see this one. Okay, now these are the labels. Okay, and here you can see the histogram. Okay, now this histogram is nothing but first for the -1. Okay, this is the first bar, this is the second bar, you can say this is the third bar. Okay, so here you can see that, okay, few are nothing but the 0 1. Okay, these are the two clusters. Okay, or you can say that the two data, most of the data is this one, and you can see the -1 is the less data as well as this one. Okay, so here, okay, in the visualization, in the next visualization, you will understand the points, okay, why we did this clustering, okay, in the three different labels. Okay, now here you can see that we are just finding out the length. Okay, we are just finding out the length of the each labels. Okay, and then we are just finding out the anomalies in the data. Okay, and here you can see that, okay, there are total two clusters and there are total how many abnormal points, or you can say that the anomaly points, which are the 39. Means in total around 9,000 rows, there are only 39 data points which shows the abnormal points. Okay, so that's how you can just go and you can find out the anomaly detection. Okay, you can detect the anomalies in your data. Okay, and here you can see that what are those points. Okay, now you see this is the anomaly. Okay, now here you have to find out where the label equal to -1. Okay, because this -1 label is nothing but the anomaly. Okay, so with the help of head, okay, total there are 39 points, and from those 39 points, okay, here you will see that the first 5 rows of anomalies. Okay, so see the in data point with index 86 is the anomaly, first anomaly. Data point with 87 is second anomaly, like this. Data point with index 109 is the third anomaly, like this. Okay, so you will find that in the data total 39 anomaly points are there. Okay, now here with this line of code, here you can simply just go and create your visualization, okay, for plotting these anomalies, okay, in the plot. Now here you can see that, okay, I'm gonna use the principal components, okay, because we just apply the anomaly detection DBSCAN clustering on the principal components. So here you will see that the because of two principal component, it's very easy to go with the visualization. Okay, so if we go with these many columns, see these many columns, okay, total I think more than 10 column, more than 15 column. Okay, so we can't visualize the 15 dimension plot. Okay, so instead of going to this, okay, we can simply just find out the two principal components and create the visualization. Okay, so here you can see that this label -1 is are nothing but the anomalies. Okay, so some here you can see that some points are the anomalies. Okay, so these total points are nothing but the, you know, the anomalies, okay, in the data. And this is nothing but the, you know, the first cluster. This is another cluster, okay, because there are two clusters. And see, after that, here you will see the anomalies. Okay, now here you can see that yes, this is looks like a circle. Okay, because there are total 900, around 900 data points. Okay, and these points are nothing but the anomalies. Okay, because here, you know, the anomalies lies in the region with less density. Okay, typically around the edges and then towards the center where the points are relatively scanned. So this is how you can just go and see or visualize your anomalies. Okay, so see guys, principal component is a unsupervised machine learning method. We are gonna use this principal component analysis method for to reduce the data dimensionality. Okay, many times you will find that your system is not capable to handle millions and billions of rows of the data. Okay, so in real-time data set, there is not only millions and billions of rows, there should be, or there must be millions and billions of columns too. Okay, so handling that type of data, that big type of data, it's very difficult to your system. So at that time, okay, it's very easy to reduce the dimensity of your data by using principal component analysis. Okay, yes, there are many methods of reducing the dimensionality, okay, dimensions of your data, but principal component analysis is mostly usable algorithm. Okay, so depends on your type of data. So if your data is in the numerical type as well as a categorical, okay, then you can easily go and you can apply principal component analysis. But what if your data is in the images? Okay, you have the data of images, you have the data of videos, you have the data of audios, then there are many different algorithms. Okay, for images you can go for the support vector decomposition, okay, to reduce the dimensionality of your image, okay, or the data you say. Okay, so here see that, okay, let me go and again the go and restart the kernel and clear the all the outputs. Okay, so after applying anomaly detection by using sklearn library, there is yet another library. Okay, and this library is, you know, you can say that the automation. Okay, because there are many libraries. Okay, but if you are beginner, so you can start with the sklearn. Okay, if you wanted to learn machine learning in by using Python. Okay, then you have this library which is Pycaret library. Okay, which is also, which is very much popular library. Okay, and it will automatically pre-process your data. Okay, see, it will just provide you the pre-processing features and all that kinds of modeling too. Okay, so that's the point. Okay, and here you can just uh, import, or you can first install the Pycaret. Okay, and how you can install the Pycaret? By using this line of code. Let me show you. Okay, yes, pip install Pycaret. Okay, many time it will ask about you the users, uh, just the access. Okay, so for that, okay, you can just go ahead and use this. Okay, or otherwise you can use this one. pre-Pycaret. Okay, so just go ahead and run this particular line of code, and many times if this will gives you some kind of error, then you can use a exclamation sign. Okay, so this will work. And many times, okay, you can install this Pycaret library in your the same Anaconda or the same environment, but I will recommend you to create the new environment. Okay, so for that purpose, okay, you have to go into the Anaconda navigator, and from there you can easily create your own new environment. Okay, and then you can use that particular environment for using Pycaret library, for applying Pycaret, means for doing the analysis of your data by using Pycaret library, because there are few libraries which will take lot of space. Okay, so then you will find that for running the code, it will take some extra time. Okay, so for avoiding that extra time, okay, then you can create your own new environment. Okay, and you can easily install that particular in package, Pycaret package, in that particular environment. So see here, there is the name here, environments. So here see, in my system, okay, I have the 8 GB of RAM, as well as I have the around 16 GB of op10 memory. So I don't need to create new environment. Okay, but if you have the less power system, okay, then you can just go here and create the new environment. Okay, just named it, okay, as any like that. Okay, Pycaret, and this is, I have to use this in Python, so that's why let me just go and create this. Okay, so it will take some time for creating the new environment, but definitely you will create the environment. Okay, after creating this environment, okay, so here you will see that there are some installed packages, as well as there are some not installed packages. Okay, like that, just go into the all or otherwise not installed packages. Okay, and search the package Pycaret. Okay, and install this. Okay, and there is another method of installing packages in Python, which is this one. Okay, just go here, open the Anaconda prompt. Okay, see here, open the Anaconda prompt, and just go here and just use the pip, okay, installer, or you can use a Conda installer. Okay, there are two installer. First one is the pip installer, second one is the Conda installer. Okay, so you can just use this install, and you can just type the package name. Okay, the package name over here. So by just typing the package name over here and just it, okay, and you will see that you will be able to install that particular package. Otherwise you can just go and use the pip, okay, pip installer. So that's how you can just install the package. And you can even install the package in Jupyter from the Jupyter Notebook itself, okay, by running the your installation code over here as well. Okay, so here also you can use the pip and Conda as well. Okay, but I already installed this Pycaret library, so there is no need to install the Pycaret library again. So that's why let me just convert this cell into the markdown cell. Okay, so you can use this particular code to install the Pycaret library. Okay, so after this, okay, and see here, okay, I just created the new environment. Okay, so see, this is my new environment. Okay, these are the, you can say that the installed packages. Okay, so now you can just go ahead and install your uninstalled packages. Okay, like here, just go here, okay, type the name and install the packages. Okay, so let me delete this. Okay, close this and see here. You can see that after this here, okay, I'm gonna use the Pycaret library for anomaly detection. Okay, so here you can see that in Pycaret library itself we have the data, okay, for performing anomalies. Okay, see, we have the lot of data, okay, and Pycaret also gives a anomaly data, okay, for performing anomaly detection on that data. So here we also perform it three-dimensional visualization by using Pycaret library. Okay, and you will find that as compared to sklearn, here you will just you will have to type the only few line of code by using Pycaret library. Okay, so see, this is the Pycaret. I am just importing the Pycaret library dot data set. Okay, this is the module in Pycaret library and importing the get data. Okay, and by using the get data, okay, I want the anomaly data. Okay, so I'm calling the anomaly, okay, by using the get data method. So after this, here you can see that I'm going to use the Pycaret library dot anomaly module, and I'm importing all the methods, all the attributes of anomaly module. Okay, so I'm gonna initialize the setup, okay, by calling the anomaly data. Okay, so means I'm gonna use the anomaly data over here in the setup. Now I don't need to use again the name of the data, okay, as well, for building the model, for creating the model too. Okay, so let's go and run this. So these are my this is my data and these are my columns in my data. Okay, so see, because this is anomaly data, and see that if some data is a very precious data, see, data is very precious for the company, but if you wanna share the data with anyone, then you can just remove the column name and type your own column names over there. Okay, then you can be able to share the information, share the data. Okay, so that's why this is the column names. Okay, so that's not the problem. Here the main thing is that we can able to apply the anomaly detection by using the Pycaret library on the data, as well as we can visualize the anomalies in our data in 3 dimension. Okay, so here you can see that in the setup, okay, in the setup what we did, okay, this is the all the description about the setup. Okay, so this is the ID. Okay, original data shape, total 1000 observation and 10 columns are there. Okay, okay, transform data shape. Okay, we didn't transform the shape of the data. Okay, here you can see that numeric features, all the columns means all the features are the numeric one. Okay, we did pre-processing, yes, true. Okay, here you can see that imputation type is simple one. Okay, because there is a thumb rule for imputation. Okay, for the missing value imputation. Okay, so you can go ahead with the mean, median or mode, okay, depending upon the columns of your data. Okay, for imputation purpose. Then numeric imputation is nothing but the mean. See, you can use the mean, median, mode. Okay, so the if your data is numeric, then you can here we just use the mean for imputation purpose. Okay, categorical imputation is constant one. Constant one is also called at the mode. Okay, then the CPU jobs equal to -1, which means how many CPUs, how many the engines in your CPUs, let's say 4 or 8 or 16 like that. So this means all the use all the engines. Okay, okay, means use total CPU to perform the task. Okay, this particular task. Okay, and stop all the background tasks. Okay, we don't have any GPU, so here false. Okay, the log experiment is false. Okay, because we don't want to do that. Okay, experiment name, this one default. Okay, anomaly default, and the USI. Okay, this is again the a term which is not important. Okay, so here this is how our data looks like. Okay, after just setting up the data. Okay, after doing the setup. Okay, so this is all about the data. So see, without any manual pre-processing, okay, we did the pre-processing, data cleaning, all the part, data transformation by using the setup only. So see, this is the automation. Okay, totally automation. And see, after this, okay, here you can see that in a one line you can see that create model iForest. Okay, now iForest is nothing but the isolation forest. Okay, many times we are gonna use isolation forest for applying anomaly detection on the data. Okay, so basically this is the one algorithm of the family of trees algorithm. Okay, there are many algorithms, okay, in the tree. Okay, as a decision, or you can say that the ensemble technique. Okay, so we have a decision tree algorithm, we have a random forest algorithm, we have a bagging algorithm, we have a boosting algorithms. In boosting algorithm you will see that the ADA boost, kata boost, okay, XG boost, extreme gradient boost, okay, like that. So there are so many tree based algorithm, and this is the one of the tree based algorithm, which is nothing but the isolation forest. Okay, so after creating the model on the data, okay, we fit the model, we make the prediction, okay, and it's ready for the predicting the future values too. Okay, so here you can see that just by using this plot model method, you can simply go and plot your model, okay, which is nothing but the iForest model. Okay, so let's go and run this. So see, sometimes, okay, so it's a totally automation process, so sometimes it will take the time. Okay, depending upon your data as well as the which particular method you are applying on your data. Okay, so see, here you can see that we just created the 3-dimension plot, okay, of our data. Okay, and here you will see that if the color is totally yellow, okay, so you will find that this is nothing but the anomalies. Okay, see, so this is how you can just go and build your model by using the Pycaret. Okay, and here you can see that this is the visualization of uh, in 3 dimension and TSNE. This is a very popular distribution. Okay, starting with the T. Okay, and as well as we are gonna use this S stands for again the one statistical process. Okay, so basically this TSNE means T distributed stochastic neighbor embedding. Okay, T distributed stochastic neighbor embedding. So basically we are gonna use the T distribution. Okay, one of the distribution of the data distribution, and we are gonna use the stochastic process in that. Okay, and the neighbors, here you can see that, okay, by the just by using the neighboring distance or the similarities between the point, we can simply just find out. Okay, that one. And here in the visualization you can see this. Okay, you can just change the size of this visualization. Okay, you can rotate this. Okay, and you can just by putting your cursor, okay, on the point, you will see that yes, here you can see that, see the value, okay, all the values feature equal to 0.28, and in the last you will see that anomaly equal to 0, which means that this particular data point, okay, is the normal data. But here see the anomaly is 1, which means this is the abnormal data point. Okay, so this is how you can just go and you can create the visualization. See, This is how you can visualize your data in 3 dimension. See, this looks very cool. Okay, and you can play with it. Okay, as well as you, if you wanted to just see sometimes data points, okay, in 2 dimensions some data points overlapped. Okay, so to avoid that, okay, to see all the data points, okay, you can just go and you can see all the data points. See, this is the data point, but if you see this data point, so see here you can find that yes, this particular data points, okay, over here you will find that this particular data points overlapped with the blue one. See, this is a blue one and this is the yellow one. Okay, so in 2 dimension it's not possible to see overlap data, but in 3 dimension you can easily just go and easily explore the overlap data too. See, so this is how you can just use a Pycaret. Okay, so after this, okay, after creating the model, which is nothing but the isolated forest, okay, model, after that, okay, in Pycaret as well, you can create, you can use another model. Okay, now this model is a k nearest neighbor, KNN. Okay, this is yet another model of machine learning, and this is a supervised model. Okay, you can use this model for the classification task as well as the regression task, and this is the anomaly detection, which means here we have to find out the data is normal or abnormal. So I can say that yes, this is nothing but the classification, na? We have to classify the data in terms of anomalies and not non-anomalies. Okay, so this is the another matter, again based on the distance, okay, similarity between the data points. Okay, so just by calling at the calling KNN, okay, by using the create model, okay, you can easily create this model. Okay, and you can plot the KNN model by using the plot model. Okay, and now here you can again see this. Okay, you can easily see the visualization, okay, in 3 dimension. Now see, sometimes it will take time, okay, to execute the cell, because in the background, okay, this is not only the building the model, fitting the model, okay, predicting the model, it is just doing all the parts, and in the end you will see that it will automatically give you the new column in your data. Okay, new column in your data which shows that that particular row is anomaly or not. Okay, here as well you can see the 3 dimension visualization. Okay, see, you can visualize the 3 dimension plot over here as well. Okay, so this looks so cool, okay, at the time of visualization. Okay, see, so after this, after building the model, after just checking the anomaly, okay, through visualization, okay, see here you can go and use your model for the prediction purpose. Okay, see here I'm gonna use the predict model, predict underscore model method. I'm gonna use the KNN method which I applied, okay, above, and if I have the new data, then I can just put that new data name over here. Okay, for making the prediction, or you also called as a future prediction. Okay, so just go and run this. Okay, and see the predicted values. Okay, now here you can see that prediction value, which means this one. Okay, this one and this one, this is the anomaly score, and this is the exact anomaly in terms of 0 and 1. So this is a anomaly of value 1, which means this is this row is the anomaly. Okay, or I can say that this is a, this particular transaction, okay, is a abnormal transaction. Okay, when we are dealing with the transaction data set. Okay, like that. So if we are dealing with the text data, so see here you will find that all the data is numeric, but what if you have all the data is in the text format? Okay, you have all the data is in the tweets format, you have all the data is in the some post format like Facebook post. Okay, you have all the data in the format of emails. So how to identify spam emails and non-spam email, how to identify the fake tweets and the tweets which you can say that the which used for the propaganda. Okay, like that. So for identifying those tweets, those emails, okay, you can even use the data science. Okay, so let's go and see the email cybersecurity threat detection problem, which is yet another application of cybersecurity data science. Okay, so let's go and see the email cybersecurity threat detection. Okay, so here you can see that this is the Spyder framework. Now up to this, okay, we were working in the Jupyter notebook. Okay, in the Jupyter notebook, this is the Jupyter notebook framework. Okay, now here you can see that this is the another Spyder. This is the another framework. Okay, now what is the difference between Jupyter notebook and Spyder? Okay, so the basic difference between the Jupyter notebook and Spyder is the professionals are using Jupyter notebook for presentation purpose. Okay, for presenting your code with explanation, okay, with comments, with interpretation. Okay, so you can present this Jupyter notebook. See, I can write many lines of the explanation about that particular topic, and after this you can not only just uh, go see in, if you are professional, then you you will have the Python. But if you are not professional, then you can just keep your this Jupyter notebooks file, okay, in terms of PDF. Okay, you can go and just convert this your file in terms of PDF, and you can present in anywhere. Okay, you can convert this into the HTML format as well. Okay, or the slides.html too. Okay, so see, so there are many ways. Okay, and if you want the dot ipynb file, which is nothing but the notebook file, Jupyter notebook file, so again you can just go and download that file too. Okay, see here, from here you can easily download the same formats file. Okay, so this is how you can use the Jupyter notebook. But if you wanted to use Spyder, so basically many developers are going to are gonna use this Spyder. Okay, and they are using the Spyder, okay, in their day-to-day work. Because see here this is okay, Spyder gives you a coding window. This is the one window is for coding. You can type your code. Okay, you can type all your code, okay, first, and then you can run the code one by one. Okay, by using, see, with this button, okay, with this I button, see, with this button you can easily run your code, one line of code. If you wanted to run all the code in a one go, means all this particular file, all the code, okay, in a one click, then you can simply just use this. Okay, this. Okay, so with this you can easily go and run this file, okay, in a one click. So here this is the Spyder framework. Okay, and here after installing the Anaconda, you not only able to open the Jupyter notebook, you also able to open the Spyder too. Okay, because see here this is a Spyder. Okay, and you can create the new shortcut on your desktop as well. Okay, so this is all about the Spyder. And here also, okay, as similar to the Jupyter notebook, we have several buttons over here. Okay, so we are gonna use this particular button many times, because I'm gonna explain each and every line of code to you. Okay, The second thing is that this is the first text window or the coding window. You can type your code over here. Okay. Now second thing is that here in the second window, here you can see that the help. Okay, you can get the help. You can just read the many tutorials about the Python. Okay, about any particular library, about any particular package like pandas package, numpy package. Okay, you can get many, just you can learn all the packages by use. Okay, from here as well as you can use this one. Okay, to just go and search about the some all about the Python references as well. Okay, then here in the variable explorer, here you will see that after running the particular line of code, okay, see if after importing the line of code, okay, if I am running the or importing particular data, so you will find that that particular data over here. Okay, in this particular window. Now in the same window, if you just click to the plots, so you will see that all the plots. Okay, you will see all the plots over here. Okay, and in the files, okay, you will see the current working directories file. This is my current working directory. Okay, so this is the path of my current working directory. I can change the current working directory's path by using this. Okay, but see here I can change the current working directory path to my original folders. Okay, where I store this particular file. Okay, but here you can see that I already mentioned the path. So now there is no need to convert or transform the current working directory. Okay, or set the current working directory. So I will go with the same code. Okay, and in the lower right corner you will see that the third window, which is nothing but the console. Okay, any line of code, okay, you are running, you will see that all over here. Okay, like that. See, if I'm going to import pandas library first, so let's go and run this pandas library. So you will see that, see, I just executed this particular line of code. Okay, now here you can see that if I wanted to import numpy library, so see, this is how I can import the numpy library. If I wanted to import this third one, sklearn, and lastly I can just go and run this. Okay, so after executing this line of code, okay, so see, after reading the data you will see that, see, this is my data, email data. Okay, this is my data. Okay, in that you can see that this is the label data. Okay, so in the first, in this video, in this window you will see that the data. Okay, and here this is the console. Okay, you can run your code in this console. Okay, so see, basically we executed this three line of code. Okay, so we know that why we imported pandas and numpy, because to read the data as well as to apply many pre-processing data wrangling steps on the data, as well as for creating n-dimensional arrays or applying some statistical analysis on the data. Okay, now here in the third line of code, okay, why we imported the sklearn, because here in the sklearn we have the one module feature extraction. Okay, and in that particular module we have another module which is the text module. Okay, now in this particular text module, okay, from this we are gonna import the count vectorizer or tf-idf transformer. Okay, now these two are the transformation. Okay, or you can say that the you can able to transform your text data into the numeric data by using these two vectorizer as well as a transformer. Okay, now I will explain this. Okay, all these things. Okay, when we come over here. Okay, at the time of count vectorizer. See, so see, let me increase this. So see, now here you can see that after importing the libraries, okay, here I just read the data, which is the email data, and this one is the label data. Okay, So label data, which means, okay, we have the one column which is a labeled column. Okay, means someone labeled the data. This is my original data, this is the text data, which is nothing but the emails. Okay, this is the emails. Okay, and this is the type of the email, either ham means a genuine email or the spam. Okay, or you can say that the some default email, or you can say that the some spam email. Okay, or the abnormal email. Okay, so this is the label data. Okay, someone already just labeled the data. Now by using this data, I have to build the model, okay, to stop this manual process for labeling the data. Okay, because see, for reading the email, each and every email, and labeling it to the spam or ham, it's very critical process. So for transforming this task into the automation, okay, first we have to build the model of machine learning or deep learning. Okay, so with the help of this code, we can able to build that particular model. Okay, so here you can see that first thing is that after reading the data, okay, now this is not the normal data, this is not the numeric data in the normal format, this is also not a categorical data, this is the pure text data. Okay, this is the pure string data. Okay, so if the data is pure text data, so at that time the pre-processing is different than the numeric data. So see here, this is my numeric data. Okay, so I apply many pre-processing steps on the data. Like that, you can see over here, I apply the standardization, I apply the normalization, I apply the principal component analysis, as well as I apply the I drop the data. Okay, I use apply the fill in a method on the data. Like that, I apply many things. Okay, now this is for the one example. Okay, I apply this many things. Okay, but there are many things. Okay, you can apply on the data. So here, if you have the text data, then the pre-processing part is totally different. Okay, as well as you have to transform your data. Okay, you have to transform your data from the text data to the numeric data. Okay, so for that, okay, again you have to use the count vectorizer and tf-idf transformer. Okay, so let me just go and show you how you can just clean your text data. Okay, and how you can apply the model on your data. So let's go and import the repackage. Repackage is basically about the regular expressions. Okay, so let me go and run this. Okay, now basically with the help of repackage, regular expression package, you can manipulate your text data. Okay, if you know some idea about the NLP, natural language processing, then you should know the stop words. What is stop word? Okay, so see, basically in natural language processing, okay, natural language processing is a term of data science. Okay, and with the help of natural language processing, you can analyze your text data. Okay, so this is the email data na? So this is the text data. So this is nothing but the application, again the application of natural language processing too. Okay, so here you can see that here I just mentioned the path. Okay, and even you can use the NLTK package for just reading the all the stop words. Okay, but I have all the stop words in the text format, so that's why I'm importing this. Okay, and I'm reading this. Okay, so now these are my stop words. Okay, now basically for finding the particular sentence, particular email is spam or genuine, so at that time, first thing is that we have to check that in that email, okay, how many times that person repeated that particular word or repeated something, okay, like that. uh, yes, it's a free thing, okay, but that particular, like a free iPhone, like that, okay. So on the basis of that, okay, we can just detect that particular email is spam or not. So for computers, okay, when we are just analyzing the each and every email by using the computer, okay, by using our system, okay, so first thing is that this, okay, for computer, this all the data, this all the emails are nothing but the data, okay. So first thing is to reduce the size of the data, which means clean the first data which is unnecessary part, remove it, okay. So that's what we are doing, okay. So I, me, myself, okay, this all these things, you, yours, yourself, okay, all these things, he, him, okay, all these words are the stop words, okay. And for in the analysis, these stop words, the unimportant, okay, means irrelevant for our analysis, okay. So for that, I'm gonna drop all the stopwords, okay. So for that, I read all the stopwords first. And here, in the yesterday session, okay, I told you about this split method, okay. So in basics of Python, okay, we learned this method, split method. So here in the natural language processing, in the cyber security threat detection problem, we are gonna use the split method, okay, and we'll show you how the split method works, okay. So see, these all are the stoppers. Now here you see the size, okay, size is 622, okay. Now it is just measuring all this size, okay. Now if we split the these stopwords by using /n, okay. So here you will see that, so see here the size, okay, 622. So let's go and run this. Now see the size, okay. Also we transform the type, okay. First we have the one, the one value, okay, I, me, myself, in a one value, okay, as a one value. But now here you will see that this is the list, okay. Now this I is the one element in the list, me is the one element in the list. Like this, we have the total 124 elements, sorry, 128 elements, okay, or the values in the stop words. So see, that's how you can create a bag of words or the list of words by using the split method, okay. But there are some pros and cons, okay, some limitation of this method. So that's why I'm gonna create one definition, one function, okay, as the cleaning text, okay. So see, this is my text, okay. So this is the text. So in this text particular, this is awesome 1231, this is the number, this is the symbols, AI, all these things, okay. So let me create this function cleaning text, okay. And I'm gonna use the regular expression package dot sub, okay, substitute method, okay, of the regular expression package. Says that just transform all these upper letter and small case, means uppercase and small case letters into the lowercase, okay. And see here, as well as, okay, here in the cleaning text, okay, we are also just saying that remove all the zeros, okay, all the numeric characters from 0 to 9, okay. Then here you can see that, okay, we are creating a one list which is the empty one, okay. And now we are using, applying a for loop, saying that just select each and every word in this particular text like this, okay, because we just transform this now. So if this is a particular sentence, so select each and every word, okay. How you can select this? By splitting the word, okay. And apply this. If the length of word is greater than 3, so just go and append the word, okay, and join into the again in the sentence, okay, and create the one sentence which is a cleaned one, and give and return that particular clean sentence, okay. So this is the function. Let me run this, and then you will understand why we did this particular programming, particular coding, okay. So this is the total function, okay, we just created. Now you will understand the difference between the split method and this function method, okay, this function. So basically this is the sentence, and I'm gonna apply split method on this particular function, and here I just use a splitter as a, or the, I just wanted to split this particular sentence wherever we have a white space. So just split, okay, according to that white spaces in the in that particular sentence. So see, this is the original sentence, okay, and I just use the split method to split the sentence and create the list of word, okay. But instead of this, if you used cleaning text, so see, cleaning text just give the output, which is this awesome, okay. So basically it removes the numeric value. It also removes the symbols and irrelevant words, okay. See, these all are nothing but the irrelevant words, so we just remove all the irrelevant words, okay. So this is how you can build your function by using the def method, okay. Now after this, here you can see this, okay, here you can see that we are applying the cleaning text on several statements. Then you will understand, okay, why we use this cleaning text, okay. Now here, see, cleaning text, this function is capable to clean our data, this all the emails. So here our main objective is to clean all the emails, because see, here in the emails you will find that some symbols, some numeric values, some all the data in the some few data in the uppercase, few in lowercase, okay. And you know that Python is a case sensitive language, so for that we are just transforming, converting data into lower case. We are removing all the numerical values, the extra spaces, extra symbols and all, okay. And means we are just clear cleaning the all the text, all the emails. So here you can see that I'm gonna use the email data, okay. I'm gonna use the text, okay. Means in the email data there are two columns. First one is the type of the email, and second is the text column. So I'm gonna extract this particular column, because I have to apply the cleaning text function on the text data only, not the first one, okay. Because first one is the label of those emails, okay, which is either the email is ham or spam, okay. So let's use the apply method to apply this particular function on the text, on the emails, okay. So let's go and run this, okay. And see, after running this, here you can see that, see, the shape of emails, okay. And here you will also see the all the location we created. The, see, we just remove the empty rows, okay. And after removing this, because here you can see that email data dot location, this is a lock, okay, stands for the location, and this is the email data. We are saying that this is the text, okay. Just extract the text, which is the one column, okay. And this text should not be equal to the empty, okay. If there is a empty, so just remove that particular one, okay. So see, there is no empty emails, okay. So now here we clean all the data, okay. See, we clean our emails, okay. See, first we have all the emails. In the email you will find that the numeric value, some symbols and all, okay. Now after cleaning you will find that we just remove all the irrelevant words, numbers, spaces, okay, all the symbols, okay, from our emails data, okay. Now it's very easy to go for the further analysis because the data is totally clean. Okay, now here our main challenge is to transform data of this text data into the numeric, because we build the algorithms. Okay, those algorithms only recognize the numeric data. They will understand the data in terms of numeric values, okay, not in the text value. So there are few methods like the count vectorizer method, TF-IDF transformer method. TF-IDF, which means stands for the term frequency inverse document frequency matrix. Okay, so this, see, we have the lot of transformers. Okay, we have the word to vec, we have the doc to vec, okay, we have the encoder as well. So many transformer we have, but these two are the most common one. Okay, and basics one, you will understand this. Okay, in a most in a very quick way. Okay, so basically with the help of these two transformers or the vectorizer, you are just converting your text data into the numeric data. Okay, so let's go and apply these things on our data. Okay, so here you can see that here we again created the function for splitting the data into the words, because now our email data is totally clean. Okay, now the thing is that we have to just check the frequency of each word in the email. Okay, because see, in the email you will find that suppose this word repeated twice or thrice in the one email. Okay, so we have to find out that particular frequency of that word. Okay, so in the count vectorizer we are doing the same. Okay, so first thing is that we have to find out the column names. Okay, so for that, okay, we are doing this. Okay, we just split our data into the words. Okay, and here you can see that means we created this function. Okay, and second thing is that we are transforming the data into training and testing, splitting the data, because now we have the data, main data. Okay, so after building the model we have to check the model is good or bad. Okay, so for that purpose we have to just check the accuracy of the model. We have to check the performance of the model. Okay, so for checking the performance of the model, okay, we have to split our model in terms of train, trace, split. Okay, so after importing train, trace, split from the model underscore selection module of sklearn library, here you can see that we are splitting the data into email train, means the training data, and the testing data. And here I'm gonna use the train test split method on the original data with test size equal to 0.3, which means I just wanted to just extract the 30% of data, okay, which is a random data in my test data set, and remaining 70% of all the data into the train data. Okay, so let's go and run this. Now you will find that this process is very simply, okay, is very simple. But here, see, this is a process which is very new for you, na? So for first time you will find that yes, there are so many steps, but see, there are in the beginning you have to learn all the things. Okay, then after that we have so many packages, okay, for automation. Okay, you can do this all these steps, okay, in a one line of code, two line of code, or may a few line of code. Okay, for performing NLP on your data, natural language processing on your data. Okay, so after this, here you can see that, okay, after splitting the data into training and testing, okay, so see, this is my train data with size 3891 data points. Okay, and the test data size is 1668. So after this I'm gonna apply the count vectorizer on my email data. Okay, So this is the first, okay, without any splitting. Okay, then after that I will go with the naive Bayes algorithm, which is a machine learning algorithm, and then I will use the train and test data. Okay, so here you can see that I'm gonna use the count vectorizer. Okay, so this is a count vectorizer. First we have this much data. Okay, all the data is the email data, and the the all the data is in the text data. Now I'm gonna use a count vectorizer with analyzer. Okay, split into words, which is this. Okay, now after applying this, okay, here, see, I'm gonna literally transform the data. Okay, from, see, the size of the data. Okay, this is the size of the data, 5559 data points, means this all the email size. Okay, so, and the columns are only two. Now after applying this, see, this is the count vectorizer, and I'm gonna apply this count vectorizer on the data. Okay, so let's go and run this. Now after applying the count vectorize on the data, so see the data. Okay, see, the format of data is totally changed. Okay, because, see, we just transform the data into the count vectorizer. Okay, now this is not the text data, this is the data which shows the frequency of each word. Okay, so there are total around 6660 words, because one column is stands for the label one. Okay, labels column, and remaining all the columns are the number of words in the data. So see, total number of words in all the emails are these unique words. Okay, these are the unique words, 6660. And total number of rows, means total number of emails we have, are this one, around 5500. Okay, so this is the shape of the data. You can just go and check the shape of the data over here as well. Okay, so we are doing the same for the training data. Okay, we are doing the same for the test data. Okay, so see, now, okay, see, we have the train emails matrix of count vectorizer and test emails matrix of count vectorizer. So this is the matrix. Okay, so now here you can see that now we finalize the data for building the model. Now we have to build the model on this data. So I'm gonna use the naive Bayes algorithm. Okay, so this is a yet another most powerful naive Bayes algorithm of machine learning, which we can use for the supervised, means a regression task as well as a classification task. Okay, and in the naive Bayes algorithm, we are gonna use the probability based method. Okay, this is a probability based algorithm, which is a very simple probability based theorem, and on the basis of Bayes theorem we created this model. Okay, which is a naive Bayes model. And after just creating the naive Bayes model, okay, you will see that it will able to give the model, the fitted model, within some seconds. Okay, because this is the probabilistic approach. Okay, so let's go and run this, import the naive Bayes. Okay, so in the naive Bayes family, we have several algorithms, multinomial naive Bayes, we have the Gaussian naive Bayes. Okay, we have the binomial naive Bayes. Okay, likewise, we have several naive Bayes algorithms. Okay, this is not the one single algorithm. Okay, naive Bayes is not the one single. Okay, there are many algorithms in the naive Bayes family. Okay, so we are gonna just import this MB, this multinomial naive Bayes, as a classifier MB. Okay, and let's go and fit the multinomial naive Bayes algorithm on the train emails. See, this is the train emails. Okay, and the type. Now this type is nothing but the, see, in the train emails we have the one column which is the type. So see, here you will not be able to see the type, but here you will just see the type. Okay, so see, this is the one column. Okay, and we transform this text data, this email data, into the all the numeric values, okay, by using count vectorizer, frequency of each word. So see, if done is a one word, so how many times this word repeated in each email, so that is nothing but the count vectorizer. Okay, so let's go and fit this. Okay, so we fit the model on the data. Okay, let's go and find the uh, ju- just the predictions. Okay, so just by using the predict method, you can simply go for the prediction, and lastly you can just find out the accuracy. Okay, now here you can see that the accuracy of the trained data is around 98%. Okay, how much? 98%. So which means that we fitted the model, and that model, okay, after prediction gives the accuracy which is 98%. 98% of the time this model is correct. Okay, so now this is the training accuracy. Okay, we make the prediction on the seen data because we build the model on the training data na? And we are make we just find out the predicted values of training data itself, so that's the accuracy of training. Okay, now we have to use this particular model on the future data, and after applying this particular model on the future data, or you can say that the unseen data, okay, unseen data, so that unseen data is nothing but the test data, because we haven't used the test data for building the model. So test data is the new data for this particular model. So let's go and see the accuracy of test data. Okay, so here you can see the accuracy of test data. Okay, so for that, first we have to use the same model, and I'm gonna apply the predict method on the test data. See, this is the test data. Okay, so let's go and run this. Okay, and see the accuracy. So for totally new data, okay, model gives the accuracy around 96%. So is this model good or bad? Yes, this is the model which is very good, because accuracy is more than 95%. Okay, so that's how you can just go and you can just build your model, those who can just find that that particular email is spam or not. Okay, so now we can easily use this particular classifier MB model, or you can say that the multinomial naive Bayes model, for checking the future emails. Okay, so many times you will see that now Google is uh, just circulating their ads, okay, saying that if the in the Google Pay, if you are performing particular transaction, okay, if you are doing particular transaction, so Google Pay uh, just just show you the one notification if that particular transaction is defective, or just you you can say that the spam one, okay, or the default transaction or fraud one. Okay, so how Google Pay did that? Okay, how Google Pay find that that particular transaction is the defective one or the fraud one? Okay, so that is totally by using data science. He applied data science in cybersecurity domain. Okay, so that's the power of data science. Okay, and in the first you will find that this all code is very large code, and see, you are not getting all the codes, you are not understanding it. But believe me guys, after see after completion of the code, okay, even this webinar you will understand around 50 to 60% of this. Okay, because this is a email, this is a real life application of data cybersecurity data science. Okay, so see, this is how you can just go for the training and testing the accuracies. And see, in more depth you can go and check the confusion matrix and the classification report. So now here you can see that this is the confusion matrix. Okay, so in the name itself you will see that the confusion matrix, okay, confusion word is there. So which means that, okay, in simple words, this is the 2x2 confusion matrix, which says that this is the correct classification. Okay, because in the emails, okay, there are two types of labels. Okay, in the email data there are two types of label. One is the ham one, genuine one, and second is the spam one, okay, the fraud one. Okay, so here this one row is for the fraud one, this one row is for the genuine one in Python. This one row, this one column is for the predicted fraud one, and this one row is for the predicted genuine one. So here this first element is nothing but the correct prediction, correct frauds. Okay, and here you will find that the correct genuines or vice versa. Okay, depending upon the emails. Okay, whether the email is genuine one or the fraud one. Okay, so see, here you can find that these diagonal entries are the correct predictions, either spam or either ham. Okay, so let's imagine in our data, if there are total 520 emails, okay, which are showing the spam emails, and total 3371 emails which are ham, which are genuine one. Okay, so out of those model predicts, okay, out of those model predict as a 3350 emails, those are actually in genuine. Okay, model predicted as the genuine emails. Okay, out of 520 fraud emails, model predicted as a 500 emails are the genuine one, are the fraud one. Okay, and this non-diagonal entries 20 and 21 shows that incorrect predictions. Okay, so first thing is that, okay, this is the genuine emails. Okay, these 20 are the genuine, but model predicted as these 20 emails are the fraud one. Okay, actually these 20 emails are the genuine emails, but model predicted as a fraud one. So that's the, you know, that's what you will see in the accuracy. Okay, 96% accuracy. If there is 100% accuracy, you can say that yes, this value should be 0 if there is 100% accuracy. Yes or no? So in the same way, here you will find that, okay, model, actually these 21 emails are the fraud one, fraud emails or the spam emails, but model predicts as these 21 emails are the genuine emails. Okay, or the ham emails. Okay, so these non-diagonal entries are the incorrect prediction of the model. Okay, but after time, okay, after getting again large amount of data, okay, so model is able to recognize again the all these these emails as the spam. Okay, and this email as the genuine one. Okay, so then our accuracy will again increased. Okay, yes or no? Our accuracy is again increased. So this is totally depends on the number of data points, number of emails you have. As you are gathering emails, okay, and you are analyzing those emails, so at that time you will automatically your model just gets updating. Okay, just updating there itself. Okay, automatically updates. So this is how you can go and you can just check the confusion matrix. Second thing is that there is a classification report. Now in the classification report, this report is again very much important. Why? Because you will find that 9% of accuracy is there. Okay, you will find that the how many data points are from the ham, means how many emails are the genuine emails. Okay, see in the support you will find that the 300 3,370 emails are the genuine email, and total 521 emails are the spam emails, fraud emails. Okay, so again, if you don't go with the accuracy, which is the 99%, okay, so you can go with the precision recall and F1 score. Okay, in short, if you wanted to check the accuracy of each class, okay, so this is nothing but F1 score is nothing but the accuracy of each class. So if the F1 score is very much close to 1, so you can say that the accuracy for predicting this particular class is very good. If the F1 score is tends to 0, so you can say that the accuracy for predicting the particular class is very bad. So F1 score here for these two classes is, for first is 0.99 and for second 0.96. So for both the classes, accuracy of the model for predicting these labels is very good. Okay, yes or no? Because of the F1 score is good. Okay, and again you can even explore the precision and recall. Okay, so see, this precision and recall, the harmonic mean of these two is nothing but the F1 score. So instead of going through the precision and recall one value, you can go with the F1 score. Yes, there is a particular situation where you have to see the precision. There is a particular situation, then you have to see the recall as well. Okay, but those situations are very specific one. Okay, so you will see those things. Okay, you will explore those things, okay, in the upcoming part while you are learning all about the data science in cybersecurity. Then you will understand these all the things. Okay, but okay, now this is all about how you can build the model. Okay, how you can build the model of email cybersecurity threat detection algorithm. We have the another algorithm, Gaussian. Okay, and you can do the same thing. Okay, with this. Okay, again we have another transformer, TF-IDF. Okay, first we use a count vectorizer, and after this you can use a TF-IDF transformer. Okay, and then you can, in that as well, you can apply the both the algorithms, no, multinomial naive Bayes as well as a Gaussian naive Bayes. Okay, so that is all about the email cybersecurity threat detection. And see, we completed, okay, we just completed all the part of this webinar. Okay, so we already saw this all the parts, cyber, what is introduction to cybersecurity, introduction to data science, introduction to Python, data wrangling using NumPy and pandas, anomaly detection, and how you can do the anomaly detection in Jupyter Notebook. Okay, you can use the same line of code in Spyder, okay, to apply anomaly detection in Spyder as well. Okay, then after this, here you can see that the email cybersecurity threat detection, we just saw this problem. Okay, we solved this particular problem. Okay,